Okay, so sorry about that. I don't know why my video completely paused. I think because it became longer than the usual. So let's just start with, in the meantime, I've cleared my screen, and let's start with the sixth question. I think we were on the sixth one, right? Okay, so the Barry, so hits a 125-meter long home run, assuming that the ball left the bat at an angle of 45 degrees from the horizontal. Calculate how long the ball was in air. So what I've done is I've copied the questions here, so I have a bit of space to write. Okay, now we don't have to erase every time. We don't want that. Okay, so okay, come on, open up. So what we need here is we need to make a diagram first. Once my cream stops hanging. Oh, come on. Okay, so I'm going to just take the draw here. Okay, now the horizontal distance that the ball has traveled is 125 meters, and the angle it is being projected is 45 degrees. So you have to calculate how long the ball was in the air. Okay, clearly this seems little lengthy because this is my motion. Okay, so how I'm going to do that is, so this is my speed at which that person must have hit the ball, and the angle was 45. This is 125 meters. I was asking how long the ball was in air. So again, if I divide this into x and y, in x my horizontal displacement is 125, and what's my horizontal velocity? If you remember from the previous video, that this horizontal speed would be, if this is u, this is 45, this becomes u cos 45, and the vertical velocity becomes u sine 45 using your trigonometry. Okay, so 125 is equals to u cos 45 times the time. So I do not have u, I do not have t, so I have to use my y direction. Okay, now as it starts from A and ends at B, what's the displacement it has in the vertical direction? 0. It's at the same height, isn't it? Unless the person is playing not on a level field. Now the vertical velocity is not 0 in this case, it's u sine theta times t minus half gt squared. I'm just taking that side. This is half gt squared is u sine theta times t. This is going to be a little difficult, so I'm just working step by step, not skipping any step. So one of my t gets cancelled. It's a starting t0. So this is a time when displacement is 0, and this is a time when displacement is 0. So you'll get two values of t. One t I'm getting rid because that's a starting time. I need this time b. So I need that. So that time t would be 2u sine theta over g. Yeah, taking this to that side, and then so I got my time. So I'm going to just plug in this time here. My theta is 45 degrees, that I know from the start. Okay, 45 degrees. So I'm going to plug in this t here. So 125 u cos 45 is 1 over root 2 times time is 2 u sine 45 over g, which is 10, 9.8. I'm taking 9.8 as 10. Now this becomes 125 equals u times u is what? U squared times 2 times sine 45 is 1 over root 2 again, and you have this 1 over root 2 here, and then divided by g. So I'm writing this 10 here. Okay, so now this root 2 is 2, this 2 and 2 cancel, so 10. So my u square is coming as 1250. You can use your calculator. So this is square root of 1250. That's my speed. Now, once I plug it, this value here, I'll get my time. That's what it's asking. For what time that was in air. So I'm going to plug my u as 1 root over 1250 times sine 45, which is 1 over root 2 divided by 10. Okay, so what I've done, I'm just going to go through it again. What I've done is I've used a displacement equation in x direction, but I didn't use u and t. So I went ahead and used a displacement equation in y direction. Because my displacement in y direction was 0, I put y as 0 here. U sine theta times t minus half gt squared. Theta is 45. Now, this half gt squared comes on the other side. So half gt squared is u sine 45 into t. This gives me my t as 2u sine 45 over g. And then just rearranging, I've got my time. Okay, you can always rewind the video and just try to do it yourself. Now let's see another one. Will Clark throws a baseball with a horizontal component of velocity as 25 meters per second. It takes 3 seconds to come back to its original height. So whatever height it was there, it takes, okay, that's not horizontal. It takes 3 seconds to come back to the original height, say. That means this entire time of flight is 3 seconds. And the horizontal component of the velocity is 25 meters per second. So horizontal range, so this is what it wants. So do we know the speed in the horizontal direction? Do we know the time? Do we have acceleration in the horizontal direction? No. So it's just speed times time. That is 75 meters. Done. And then it wants its initial vertical velocity. So it needs this. We don't know this. And it also needs the angle at which it was projected. So they need this angle theta too. So fine, I got the range. And then I'm going to use the time that I've derived here. So again, let me just derive it. It just helps us. So how I'm going to find out time? By using y direction displacement as 0. So this is ut plus half at squared, which is 0. U is the vertical velocity, which is u sine theta, times time is 3 seconds. And because the speed is upwards, I have to take acceleration as negative, times 10 times 3 squared is 0. So I'm going to write this as u sine theta times 3 minus, this is 5, 9, 5 so 45, minus 45 equals 0. So this gives me u sine theta as 45 divided by 3, 15. So I got my vertical velocity, which is u sine theta, as 15. And my horizontal velocity, which is u cos theta, as 25. Now, how do I calculate theta? So when you have the vertical velocity, so if you see, this is a bit of your trigonometry. So if you divide this by this one, u cos theta, 25, what you get is tan theta. So my tan theta is coming as 3 over 5. Use a calculator, find theta. That's it. We got the angle of projection using this. We got the vertical velocity as 15 because we used displacement in y direction as 0. We knew the time of flight. It's just more steps. It's not difficult. It's just more steps. So keep your head calm, draw the diagram, see what's given, and proceed. There's only 2, 3, just as you can see, just use 2 equations. One equation, ut plus half at squared is the displacement, nothing else. Okay, keep your head calm. Most of the time, it's the it's the nervousness that we have when we see a question brings us into trouble. If you just keep your head calm and keep solving it. Okay, let's try this one. A tennis ball thrown at a velocity of this much at angle lands exactly 3 seconds later on the top of a building. Say, so I have a tennis ball being thrown, this is 25, at angle 53.1. It hits the top of some building. Okay, so this is my building, let's say. That's my building. Okay, that's my building. Exactly 3 seconds later. So my time for which it was in air is 3 seconds. So we want this horizontal distance. Calculate the horizontal distance and the height of the building. So that's my y. Now, the first thing I need to do is get my velocity in x and y direction. So this velocity would be 25 cos 53.1, and this one is going to be 25 sine 53.1. Okay, so I'm going to simply write x. I'm going to just do it like step by step. So my displacement in x direction is ut plus half at squared. Acceleration in x direction is 0. So in u in x direction is 25 cos 53.1 times time is 3 seconds plus 0. Done. So this becomes x equals 25 times 3 is 75 cos 53.1. I do not have a scientific calculator in my hand right now, so I'm just going to leave it here. And then y, same formula. Okay, I'm going to just say same because it's a displacement. So ut plus half at squared. Y gives me the height, and the u in y direction is 25. This one. Okay, so let's just write 25 sine 53.1 times 3. It's the same time, but now, okay, so this is one of the other mistakes which the students make. When to take a as negative, when to take a as positive. Just see, if your velocity is in the upward direction, which in this case is, your a will be negative. If your velocity is in the downward direction, your a will be plus g. Do not make this mistake, because you're working so hard in understanding this concept and then just a plus and minus problem and you lose your marks. We don't do that. So 75 sine 53.1 minus, this is 9 5s of 45, and then just figure out, just hold on, let me just find out if it could be my scientific calculator. Just hold on. Alright, I can't find it. Say let's just leave it here. Or yeah, okay. Let's understand the concept first. Calculations I can teach you in some other video. You don't need them, but if you need them, let's do this one. A golfer can drive a ball with initial speed of 30 meters per second. So what we have is now 30 meters per second. So what's the angle? Now that's the trick here, that we know what's the angle. Okay, so the angle is not known. All right, that's what they have asked. All right, so I'm just going to the ball and the same level. So T and the green. Okay, I can't draw a straight line, can I? Okay, so this is the path that's followed. This distance is 80 meters. If you think that you have a little bit of confidence now, just pause the video and just try to do it yourself. So we need the angle theta. Okay, so it's just me. Whenever it's an angle, I can take the angle as x, y. I just always take it as this symbol, which is called theta. It's a Greek alphabet. Okay, same thing, x and y. So x is 80, speed is 30. So that's my first step. I write the speed here. So that's my 30 cos theta. And the vertical velocity would be 30 sine theta. Alright, so 30 cos theta times time. Plus part would be 0 because, what do you think? What's the reason? Yeah, you're right, because acceleration is 0. Okay, yeah, so we are learning. Well done. Okay, so we got it. But we don't have time, we don't have time. We don't have, okay, so we don't know theta, we don't know t. Two unknowns. So I need one more equation. My displacement in y direction is 0. So I'm going to use ut plus half 80 squared as 0. My u is in upward direction, so my a will be negative. So 30 sine theta times t minus half 10t squared is 0. So 30 sine theta t is equals to half times 10 times t squared. So again, I'm cancelling 1t because that's the time of the start. So this is the time when it is 0. So t equals to 0. I need this time. Okay, so my 30 sine theta, so this is 2 5s, divided by 5 will give me t. So 5 6, so 6 sine theta is my time. So I'm going to plug it here. So 80 equals 30 cos theta times 6 sine theta. So that is 180 cos theta sine theta. Now this one here is, I don't know, if you have done this formula, 2 cos theta sine theta equals sine 2 theta. In this is a helpful, so double angle formula, it comes from maths. So what I'm going to do is I'm going to plug in cos theta sine theta. So what would be cos theta sine theta from here would be sine 2 theta divided by 2. So I'm going to, and this 2 and 2 does not cancel. Okay, do not cancel them. So 80 equals 180 times sine 2 theta divided by 2. So if I just simplify this, I'm going to simplify it here. So this is 80 times 2 divided by 180 is sine 2 theta. Okay, cancel 4, 9. So my sine 2 theta is coming as 8 over 9. And then you solve it using your calculator. Find the sine inverse and then half it, because this is a double angle. So find the sine inverse of 8 over 9 and then half the angle, because it'll give you, so when you do the sine inverse, it'll give you 2 theta. So sine inverse of 8 over 9, this you do with your calculator. Whatever answer comes, divide by 2 and you get the angle of projection, because the angle at which it is thrown is theta. It's not 2 theta. Right? I hope you get it. Okay. If you're struggling with using your calculator for these parts, from next time I'll remember to keep a scientific calculator in hand. Okay. How long will it take a shell fired from a cliff at an angle, at an initial velocity of 800 at 30 degrees below horizontal to reach the ground 150 meters below? All right. This sounds like lots of calculations. Okay, I am not going to start the question till I draw the diagram. That's what you should do. So to pause my video and you try to make your own diagram. Okay, and I'm going to try making mine. How long would it take a shell fired from a cliff? So for me, the cliff is a straight line. At an initial velocity of 800 meters per second, 30 degrees below the horizontal. So this is the horizontal. So 30 degrees below the horizontal with speed of 800. Okay. So this is my ground. Now, before I attempt anything, I need to break this velocity into its horizontal component, which is 800 cos 30, and the vertical component, which is 800 sine 30. Okay, now y downwards, that comes from your vectors. If the resultant velocity is downwards, my vertical will be this and my horizontal will be this. Now, the level ground, which is 150 meters below, how long does it take? So which direction should I use? Should I use X or Y? So in which direction do I know most of the things? Okay. I do know the velocity in X direction, but I don't know the distance in X direction. So kind of X, no X. Now what, Y? Do I know the velocity in Y direction is 800 sine 30, and sine 30 is half, so 400. And because the velocity is in downward direction, my acceleration will now be positive 10, 9.8, but 10, okay? So I'm going to use, and what is my Y? How much is my displacement? That is 150. Okay, so I'm going to use my equation now. So using Y is equals to ut plus half at squared. Y is 150. U is 400 times time, I don't know, plus half 10t squared. Okay, so I'm going to divide the entire equation by 10. This is going to give me 15, 40t plus half t squared. I'm going to times the entire equation by 2, so that I don't get this 2. So this is 30 80t plus t squared. So you know where we are headed, isn't it? It's a quadratic equation. Minus 30 equals 0. So I'm just going to use the formula here. If you remember this formula, minus b plus minus under root of. Okay, this is the formula I'm going to use. So I'm going to compare it with the standard equation. A is 1, B is 80, and C is minus 30. So the equation for time is minus 80 plus minus under root 80 squared minus 4 times 1 times minus 30 is 2. Of course, you know, this is you can always, if you are using a scientific calculator, the graphical calculator, you can always plug in this and it'll give you the final answer. Okay, I'm just doing for those who do not are not allowed the calculators. So 6400 and plus 1200. Yeah, no, sorry, 120, not 1200. Divided by 2, so this becomes 6400 and 120, 0256. So yeah, so then just use your calculator to find the square root, and then that gives you the time. So obviously you will have two values of time. One would be negative, one would be positive. You just ignore the negative because time can never be negative, and then just proceed ahead. So this is basic two-dimensional motion questions, either with the projectile or without the projectile. Now next class, next video, I will solve Edexcel exam questions, AQA exam questions, and many more. All right, till then, keep learning. Bye bye.